students, today we are going to start exercise 1.4 that is related to decimal form or decimal representation of a rational number. If you want to learn about the types of decimal representation, then I will put the link in my description box. You can easily learn the types of the decimal forms from that video. Now we are going to start. Question number 1. Without actually performing a long division, state whether the following rational numbers will have the terminating decimal expansion or a non-terminating decimal expansion. First question is 13 over 3125. We know that this is of the form P over Q, and first of all make the prime factors of the denominator. 5, 6 5s are 30, 2 5s are 10, 5. Again divided by 5, 5 1s are 5, 2 and 5. 5 25, 5 5s are 25, and it can be written as 13 over 5 into 5 into 5 into 5 into 5, or 13 over 5 raised to power 5. Which is of the form P over 2 raised to power m 5 raised to power n. If we want to properly in this form, then we can take 13 over 2 raised to power 0, because we know 2 raised to power 0 will be 1 and 5 raised to power 5, and now it is exactly of this form, which is of the form this, and a rational number whose denominator, or we can say Q, is of the form 2 raised to power something, 5 raised to power something, is of the form terminating decimal expansion. So 13 over 3125 is of the form terminating decimal expansion. Question number 2. 17 by 8. Again make the prime factors of 8. 2 4s are 8, 2 2s are 4. That will be 17 by 8. 2 into 2 into 2, 17 over 2 cube, and it can be written as 17 over 2 cube into 5 raised to power 0. Again, which is of the form P over 2 raised to power m 5 raised to power n. So it has terminating decimal expansion. Question number 3. 64 over 455. Again we shall make the prime factorization of this number, that will be 5, 9, 1, 7, 30. It will become 64 over 5 into 7 into 30, which is not of the form p over 2 raised to power m 5 raised to power n. Therefore, it is non-terminating decimal form. Question number 4. 15 over 1600. Again, prime factorization. This 2, 8, 2, 4 here, 2, 2, 200, 2, 50, 2, 25, 5 5s are 25, and it can be written as 2 raised to power 1, 2, 3, 4, 5, 6. 2 raised to power 6 into 5 raised to power 2, which is of the form p over 2 raised to power m 5 raised to power n. Therefore, it is terminating decimal form. Sixth question is 23 over 2 cube 5 square. There is no need to make the factors, already factors have been made. So, which is of the form p over 2 raised to power m 5 raised to power n. So, it is terminating decimal form. Next question 7 is 129 over 2 raised to power 2, 5 raised to power 7, 7 raised to power 5. Now, denominator is already in the form of factors, which is not in the form p over 2 raised to power m into 5 raised to power n. Why? We need only factors 2 and 5, but here we have 3 factors 2, 5 and 7. So it is not of the form 2 raised to power n m into 5 raised to power n. Therefore, it has non-terminating decimal form. Question number 8 is 6 over 15. Again, factors of 15 can be written as 3 into 5. Again, 5 is a factor, but 3 is not in the form of these factors. So, we shall write which is not in the form p over 2 raised to power m 5 raised to power n. Therefore, it has non-terminating decimal form. And ninth question is 35 over 50, and factors of 50 will be 25, 5 5 is 25, 35 over 2 into 5 square, because 5 is multiplying 2 times. Again, which is of the form p over 2 raised to power m 5 raised to power n. Therefore, it is of the form of terminating decimal form. And last question is question number 10, 77 over 210. Again, we shall use prime factorization. 2 1 0 5, 3 3s are 9, 5 3s are 15, again 5 7, and it will become 2 into 3 into 5 into 7. And there are lot of factors except 2 and 5. We are getting 3 and 7 also. So it is not of the form p over 2 raised to power m 5 raised to power n. Therefore, it has non-terminating decimal form. Thank you.